Welcome back to my channel Physics Foundation Mastery Hub. In this particular video, I'm going to discuss about the differences between a real image and a virtual image. Let's get started. How are the images formed? I explained it in detail in my previous video. If you have not seen it, the link for it is in the description box. Please do check out. Anyway, if I have to summarize the entire process of image formation, we need to understand few important concepts. What are they? Here I have put down. The first aspect is the rays which come out from the object contains the visual information about the object. For example, let us say you have a flower. The rays which are coming out from this object is very important because those rays give the entire information about the visual information about the flower, the color, the size, the shape, etc., etc., etc. So these rays which are coming out from the object are very, very important. Second, if the path of these rays are changed either due to reflection or refraction. So the path of rays are changed due to reflection or refraction because of presence of an optical element like a mirror or a lens. If you have a mirror, what takes place? What takes place? Reflection takes place. If you have a lens, refraction takes place. Or if you have a medium interface, again you will have refraction taking place. Now, number one, these rays which are coming out from the flower, they are very important because it contains the visual information about the object. Secondly, these rays, the path of these rays are changed due to the presence of the mirror here. How does it change? Now we know the laws of reflections, we know. So these rays, they get reflected like this. I'm trying to be as accurate as possible. And then what? The way our brain works. So we discussed in the last video that the eye and brain system, this entire system works in a way that we strongly feel, the brain strongly feels that light can only travel in straight line path. That means when these reflected rays, what are they? These are all reflected rays. How many of them are there? Not just two, there are infinite. This is one ray, this is another ray. There are in between, there are infinite number of rays and all of them are getting reflected, and these rays, when it arrives at my eye, what do I feel? I feel that all these rays must be coming from somewhere. You see, actually what is happening, the rays are getting bent here, but my mind is not ready to accept that fact. That's how the brain is designed. Brain feels that light can only travel in straight line path. My mind can't get the idea that these rays are actually getting reflected here and coming. No, my mind feels, okay, these rays must be coming from somewhere here. So what do I see? These reflected rays contain the same information about the flower. So what I see here is the same flower. I see the same flower. So basically, it appears that these reflected rays are coming from here and I feel flower being present here. So what is this? This is basically the image of the flower. So this is basically object. At this point, I want to tell one very, very important concept. Please make sure that you get that right. So these two rays, sorry, there are infinite rays. Basically, these rays are called incident rays. These are basically incident rays and these are reflected rays. So technically, and now what is taking place is the central figure in this entire situation is basically Mr. Mirror, okay, or Miss Mirror, whatever you want to call it. Okay, so these are incident rays on the mirror and these are reflected rays. So technically there is a term called as object. Now, what is an object? Hey, come on. What do you mean by object? Everything is object. This is an object and this is another object. Everything, every item that you see around, it's an object. What is the big deal? However, here I want to say something very important. Now in optics, the meaning of object is basically, it is with respect to the optical element that we are discussing. For example, here what is taking place is light rays are falling on the mirror and it is getting reflected. So the central person, important person, is basically mirror. So with respect to mirror, we are basically speak what is an object and what is an image. So object, the definition of object is where incident rays meet. Where, so object is at that place where the incident rays meet. For example, look at this situation, sir. Here is the mirror and these are the rays which are falling on the mirror. Now for the mirror, these are incident rays. Where are these incident rays are meeting? They are meeting at this point. Okay, so basically here is what my object is. This is my object. What is my object? Basically mirror's object. Object is here. Where the incident rays meet, that is called as object. Okay. Similarly, what is an image? Again these definitions, object, image, etc., they are all with respect to, specifically here with respect to mirror. Now what is an image? The definition of image is where reflected rays or refracted rays. Here we are speaking of mirrors as of now. Basically where reflected rays meet, that is basically image. However, if you have a lens here, then you have to say refracted rays. So let me put everything together, both of them together. Where reflected or refracted or refracted rays meet. Alright. So object is where incident rays meet, that is the position of the object. In this case, you have mirror and these are the incident rays, and these incident rays, they are actually meeting here. They are originating from here. So this here is my object. Of course, it is flower here, flower. And image is where reflected and refracted rays meet. Now look at these rays. Now these are diverging rays. Okay, they are diverging rays. As they go forward, are there any place where both of them meet? They never meet. However, these two rays appear to be coming from here. Alright, these two reflected rays, are they actually meeting? They are not meeting, but these two rays appear to be coming from here. So they appear to be meeting at this point. Okay, so such an image is called as virtual image. So image, you have two types of images. One is virtual image. Just now I have spoken about it. What is virtual image? The reflected rays. See, what is an image? Where reflected rays or refracted rays meet. But in a virtual image case, actually the reflected rays do not actually meet, but they appear to meet. So virtual image is when reflected or refracted rays do not actually meet. But only appears to diverge from some place. Here it is this point. From here it appears to diverge from. That's how my eye feels that there is an image here. This is basically virtual image. However, a real image is when actually reflected rays actually meet. Okay, reflected or refracted rays actually meet. Okay, actually meet. Now, in order to, I have already given the example of virtual image in the case of plane mirror. In order to explain real image, I'll have to get into spherical mirror. So let's get to that. Let me explain about the formation of a real image using a spherical mirror, especially a concave mirror. Now, what is a spherical mirror? It's very simple. Let's take a glass sphere. Let's take a glass sphere, not solid, hollow. Okay, glass sphere, and just cut off some portion of it. Now, if I see this in 3D, how does it look like? It looks like this, a cup. Okay. Now, if I silver the outer portion, basically the outer portion you are making it opaque. So what happens is the inner side of this part acts as the mirror. So this is basically concave mirror. So let's look at how it works. We have a concave mirror. Now, concave mirror is a part of a sphere. It is part of a sphere. So many a times when we start discussing about concave mirrors, etc., what I observe is students become little scary. But please understand, it is very simple. All that you have to do is you have to draw the reflected rays, the incident rays, and see where the reflected rays are meeting. As simple as that. Okay, as simple as that. Somebody may say, sir, it is very difficult to draw the ray diagram. Till now, whatever we have been drawing, they are called as ray diagrams. It is difficult to draw very nicely. Yeah, that is true. However, there are certain tricks and rules that we follow to make the entire process very simple that eventually I will discuss. But anyway, what we are trying to say is, in place of plane mirror, you have a spherical mirror. Nothing to get panicky about. Very simple. Let's start. And as I said, this mirror is a part of a sphere. So if I imagine the entire sphere, so oh God, I have not drawn a very nice thing actually. This may be the dotted line is the actual sphere of which this mirror is part of, and the center of that sphere is called as center of curvature. This point C is called as center of curvature. Just remember, I'm not discussing everything, but anyway, and the exactly middle point of the mirror is called as pole. P is for pole, and the line joining C and P, this line has a name called principal axis. It is called principal axis. Anyway, all those things, technical things, forget. Now let's get into a case where you have been given an object and you are asked to find the position of the image. Very simple. Let us say you have an object like this. Now you would have asked, you would have seen before also, in the last video also, I have drawn an object like this. Hey, what's this object? Actually, this object may be a tree or it may be a person, whatever. It has certain linear dimension. Instead of drawing a tree or a person, we just put a arrow. Okay. So anyway, let us say you have an object here. Say the bottommost point is A, the topmost point is B. I want to find out where is the image of this object as formed by this concave mirror. What are we supposed to do? First, draw incident rays. Now, This is an extended object. It is not a pointed, it's not a point object. So from every point on the extended object, light rays originate. So the most important point is B actually. In order to find the location of image, always take the top point of the object and draw any two rays. So which rays they must be, so that it will become a little easier. We will discuss it maybe in the next video. But anyway, let's make it, let's take any two rays. I will take one ray which is passing through the center of curvature itself. The center of curvature. Now what is speciality about this particular ray is, this is going to be normal incidence. This is going to be normal incidence, because from center to any point on the sphere, if you draw a line, that line is going to be perpendicular to the mirror. So basically what happens, this ray reflects just back. The reflected ray is going to retrace back, right? Very simple. Now let us take one more ray, maybe which strikes at the pole. Which strikes at the pole. Again, this principal axis itself is the normal. The principal axis itself is the normal. Again, from center to any point on the sphere, it is going to be perpendicular. This angle is basically perpendicular. That means the CP line is basically normal at the point of incidence. So this is the angle of incidence. This is the angle of incidence. So the ray has to reflect in such a way that reflected angle is the same. This is I, this is R, which must be I. So this is the reflected ray. Now we have taken two incident rays, which are 1, this is 2. Where are the reflected rays for them? This itself is one reflected ray. This is 2R reflected ray for this second incident ray, and this is 1R. This is reflected ray for the first incident ray. Now look at these two rays. One ray is coming like this, the other ray is coming from like here. So basically the two reflected rays are meeting at this point. The two reflected rays are actually meeting at this particular point. So the point B, when these two rays actually, if they reach my eye, what I feel is the position of B is somewhere here, or the image of this AB is formed here. That means something like this. B appears to be here, A happens to be here. Alright, so what you see is it gets inverted. Now actually what is happening? There are reflected rays. So one reflected ray is from here and the other reflected ray is bouncing back. So these two reflected rays, they are actually originating from you. Similarly, from every point here, you will see that reflected rays originate from the position of image. So we can call it as B dash, B dash. So the image which is formed thus, it is a real image. It is a real image. Why it is real image? Because the reflected rays are actually meeting. One reflected ray is coming like this, the other reflected ray is coming like this. So basically the meeting point is B dash. So these rays, when my eye receives these two rays, infinite rays, what happens? I see B at this point. I see B at this point. So I am calling it as B dash. So one more very important thing that you see, it is also inverted image. It is also inverted image. So this is basically real image. So real image, because actually rays are actually meeting there, real image can be captured on a screen. Can be captured on screen. For example, if I place a screen here, white screen here, these rays when they meet here, so what happens is I can see AB here. Looking from my eye has to be here. So basically, example of a real image which is captured on screen, a very good example is a movie theater screen. Actually, you are seeing a grand movie. Nothing is there. It is a just white screen. What is happening is the overhead projector is actually sending the rays, and those rays are actually meeting on a screen, and which again gets reflected, and I see. If I put a screen here, what happens? these two reflected rays are actually meeting, and further again it will reflect back from a particular point. So what happens? I see B on the screen. Okay, the reflected rays from the screen, again when it reaches my eye, I can see the real image. Okay, of course, if your eye is here, when these two reflected rays are coming out here, you also can see this entire image. So one very important thing, if you place a screen here, once a real image is captured on screen, you can see the real image from anywhere. For example, in a movie theater screen, you can see the movie sitting from any position. Is it not true? However, if there is no screen here, you can only see this image if your eye is within the path of light. If my eye is here, if these rays reach my eye, then only I can see A dash, B dash. This is very important. So let me summarize whatever we have discussed. Real image and virtual image, if I have to summarize, virtual image is basically formed in a position where there are no reflected or refracted rays at all. So virtual image and real image, if I have to summarize, virtual image is formed in an area or in a region where reflected or refracted rays are not present at all. For example, the image of the flower is being formed behind the mirror. Behind the mirror, there are no reflected rays. Reflected rays are coming from the mirror. But I see an image behind because of that's how the brain is made. So virtual image is formed in a region where reflected, refracted rays are not present at all. Okay. However, a real image is formed where reflected or refracted rays actually meet. Second very important point about virtual images, it cannot be captured. It cannot be captured on a screen. In order to see the object, you have to look into the mirror. You can't capture the image on a screen so that from anywhere you can see. That is not possible for virtual image. However, for real image, it can be captured on screen. Now, very, very important thing I'm going to say. Very, very important thing. Many times students get confused with this aspect. Virtual image, I'll just write it as VI. Virtual image formed due to single reflection or refraction is always upright. That means if the object is upright, the cap is above, the image is also formed as it is, the cap above. Okay. But if the object is like that, image is inverted, just like what we have seen it in the concave mirrors example. That is basically an inverted image. Okay. So what we are saying is virtual image formed due to single reflection or single refraction is always upright. Upright is also called as erect. It's also called as erect. However, we cannot say that virtual image is always erect. We also can have, this is very, very important, we can have a virtual image which is either erect or inverted if we have two or more optical elements. What do you mean by optical element? mirror or lens, whatever. Okay, all of them are. So if you have only one mirror or one lens, then the virtual image so formed is going to be erect. There is no possibility that it can be inverted. However, if you have more than one optical element, you have more than one lens, more than one mirror, etc., then you can have a virtual image. You can have virtual image even inverted. Very important. Same thing we can discuss for real image as well. Real image as well. So real image formed due to single reflection or refraction is always inverted. Is always inverted. So real image, if it is formed due to single reflection or refraction, what we have seen was you have a concave mirror and the image formed, it's only one single concave mirror. It is basically real image formed due to single refraction. It was inverted, we have seen it. So it is inverted. However, a combination of two or more optical elements can produce a real image which is either upright or inverted. Upright and erect, they are same, upright or inverted. So this is all about real image and virtual image. We'll meet in the next video. Thank you so much.